Alright, so our testing method was FTIR, which stands for Fourier Transform Infrared Spectroscopy. And what it does is used to identify organic and sometimes inorganic materials. So FTIR, how it does this is it exposes molecules to infrared radiation. And these molecules get excited when exposed to infrared radiation and vibrate more than they would at rest. And the wavelength of light absorbed by a material is a function of the wavelength difference between the molecule at rest and the molecule after irradiated. And this wavelength function is very specific to the molecular state of a material. So we're able to use that wavelength function to identify what material it is. We could use FTIR and test solids, liquids, or gases. And our 4 or 5 samples were all solids, and they are cotton woven, acrylic woven, polyester woven, and then polyester cotton jersey knit, and nylon woven. Cotton woven was our first sample. It is a 99% cellulose, which is a macromolecule, so it's made up of long chain glucose sugar molecules. Our second test was acrylic woven, which is made up of polymer polyacrylonite with an average molecular weight of 100,000. And it's something interesting, to be acrylic in the US, the polymer has to be 85% acrylonitrile. Our third test was polyester woven. It is a long chain polymer. It is purified terephthalic acid, PTS, or in some cases dimethyl terephthalate, DMT, and then monoethylene glycol. So those are the compounds that make up polyester woven. Polyester cotton jersey knit, it shares the compounds of both polyester and cotton, and usually it's around 65% to 35% polyester or cotton to polyester, but it can also range to 50-50. And then our final thing we tested was nylon woven. It's appropriate monomers combined to form a long chain via a condensation polymerization reaction. 2 very common ones we learned in class were nylon 6 and nylon 6,6. Nylon 6, its base is caprolactam. I'm sorry if I'm mispronouncing these. And nylon 6,6 is adipic acid and hexamethyllenediamine. So yeah, that's that.
There are 4 relevant standards for an FTIR experiment. ASTM E168-16, Standard Practices for General Techniques of Infrared Quantitative Analysis. ASTM E334-01, Standard Practice for General Techniques of Infrared Microanalysis. ASTM E1252-98, Standard Practice for General Techniques for Obtaining Infrared Spectra for Qualitative Analysis. And ASTM E1421-99, Standard Practice for Describing and Measuring Performance of Fourier Transform Mid-Infrared Spectrometers, Level 0 and Level 1 tests.
Hello everyone. For our MIL project for MSE 3720, our group used the Fourier Transform Infrared Spectroscopy process in order to identify our different materials. What we're going to be looking at is sending a beam of electrons at our different materials and figuring out how they are reacting to this beam, figuring out their different absorptions and wavelengths and frequencies in order to identify different kind of functional groups in the actual materials so we can identify what we're actually working with. So now we're going to give you a step-by-step process of how exactly we're going to use this machine. So now we're going to show you the actual process of using the FTIR and getting results that we can analyze later on in this video. So if you look at the Omnic software that we have pulled up right here, setting our experiment to MIL default for the FTIR, first what we're going to do is collect our sample data. When we do that, we're going to enter in our team name. This is going to be test 1 for material 1 for MSE 3720 FTIR team 2. Now, in order to have proper results, we need to have our FTIR take in background for everything that's going on in the lab so it can provide more clear results. So, what we're going to do is let it run without a sample present. We have our FTIR picking up background in this position, and we will go ahead and let the machine run. As you can see at the bottom, this progress bar telling us how close we are to finishing, and we can see the different wave numbers for our background counts, which will set as a basis and help us discriminate between the sample we're actually looking at. Alright, now it is asking for the sample. So we're going to take material 1, place it right here on the metal pad, bring our reader right above it, and going to rotate down until we feel a click, which I just felt. We are good to go, and we will hit collect sample. And now you can see here the new different wave number peaks and variations that we'll be using later on in our analysis to figure out what exactly this material is.
So we have cotton woven here. This is our IR spectra that we collected, and the structure is shown in the middle. And what you can see here is we have plenty of hydroxyl groups, which is indicative at 3,300 inverse centimeters. It tends to be a very wide, broad peak. We also have a lot of CO stretching going on between just the rings themselves and then between the carbon and the alcohol groups. So those can be seen around 1,000 inverse centimeters to 1,050 inverse centimeters. There's a large group of them. That's why it's not a defined peak. For acrylic wovens, here's our spectra, and the structure is shown. What you can see here is we have a C triple bond N stretch that usually occurs around 2240 inverse centimeters. We also have a CH2 bending that's occurring at 1465 inverse centimeters. For polyester wovens, we have a C double bond O stretch that's usually due to an ester around 1710 inverse centimeters. This is a very sharp and very distinct peak. We also have a couple of CO stretching peaks that are happening around 1100 and 1250 inverse centimeters. They're distinct because the bond between C and O are different between a carbonyl and then between an aliphatic chain. For our polyester and cotton jersey knit, there wasn't a huge difference between the previous one with just polyester, as you can see, and the same kinds of peaks are showing up with a C double bond O stretch due to an ester at 1710 inverse centimeters, and the CO stretch at 1100 and 1250 inverse centimeters, and that could be due to just how the blend is, with maybe it could be a 90 to 10% polyester cotton knit, or just something that makes polyester more dominant in the spectra. And in our final sample, we have nylon woven. Primary functional groups are the NH stretch for a secondary amide. That's appearing around 3300 inverse centimeters. It's just one peak for a secondary amide, so that's a very distinct peak to see. And we also have an NH bend at 1550 inverse centimeters, as well as C double bond O stretch for amides, which is occurring at 1630 centimeters, inverse centimeters.
Now, because when I hit collect sample, okay, and I'm just gonna do.
There's a nose.
What's going on? Thank God, my family first and foremost.